Hello. Today I am going to have you look at Unit 1, Lesson 4 in this video, and hopefully you'll find this is a review from what you've done in the past. So if you want to find this lesson in your notes and get started here, our goal for today is to talk about solving equations with special cases. So sometimes we don't just get an answer, and sometimes we get a no solution or an infinitely many solutions. So we will talk about that. All right, so what I first want to start with here is across the top, A, B, C, and D. So I want you, without solving algebraically, so I want you to sort of use mental math. Think about what the answer is. What value of x will make each equation true? So like the first one's should be pretty quick and easy. 2 times what number equals 14? So 2 times 7 would equal 14. So 7 would be our answer. So letter B, you're doing 3 times what number minus 4 gives you 8, and so forth. So I want you to pause the video, and I want you to think about what value of x would make these equations true. So go ahead and pause, and then come back when you have an answer. Okay, letter B, 4 is going to make that true, because I would have 3 times 4 is 12, take away 4 is 8. Now on this one, the answer here is any number makes it true. 2 times a number plus 5 is always going to be equal to 2 times the same number plus 5. So I'm going to just say here like all values, okay, or any number in the world would work. Letter D says a number plus 1 equals a number plus 3. Well, these numbers have to be the same. So there is no value that I can add 1 to it and then add 3 to it and get the same answer. So I'm just going to say here no values. Okay, so when we get this to happen, we have a special phrase we'll list for it. So in this section here, there are 3 designations for types of solutions. So we're going to have 3 categories. So the first one will be if we have one solution. So I'm going to put number 1 over here. I'm going to write one solution. Okay, and then I'm going to come back to this in just a minute. So I'm going to put kind of a little divider line here. Number 2. Number 2 will go along with letter D up here. What if there's no solution? So we would call that no solution. All right, and then separate out for number 3. This will go along with letter C. What if there's lots of solutions? So number 3 we call infinitely many solutions. Infinitely many solutions. All right, let's go back to one solution. So this is your typical equation where you get like x equals 5, x equals 1. So I'm just going to write you might get something like x equals 4, x equals negative 7. So this is what I would call the normal case. This is what we spend a lot of time in math doing. No solution. Now, no solution and infinitely many solutions are similar in some ways, but different in the other. So kind of bullet point number 1. What happens here is the variables eliminate. Variables eliminate. Okay. And then you're just left with a number equals a number. So if that's false, there's no solution. So I'm going to write here false statement. Okay, so maybe you're left with 4 equals 7. Well, that's obviously not true. So 4 is not equal to 7. That would be called a no solution. Infinitely many solutions, we still get variables to eliminate here. Variables. I'm just going to do ELIM for eliminate. Now we have a true statement. So variables go away and we're left with 1 equals 1. Well, we would say, well, there's infinitely many solutions because no matter what x is, we get 1 equals 1. Okay, so if we end with one solution, we're going to write the answer, what is the solution? Don't write the phrase one solution. We're going to write like, x equals 4, x equals 7. Okay, so let's go through some examples here and solve these out. All right, I'm going to kind of switch back and forth colors. All right, step 1, I am going to distribute over here. So let's bring down 4 minus 4y. And then I have negative 2 times 2y is negative 4y. Negative 2 times negative 2 is positive 4. So I'm going to work with variables first here. So I'm going to look at this and say, let's add 4y to both sides. Well, this adds up to 0, and so does this. So my variables are eliminating here, and I am left with 4 on the left-hand side and 4 on the right. So I don't have one solution. I have one of these two here. So if 4 is equal to 4, that's true. So this isn't infinitely many solutions. Doesn't matter what I plug in place of y, I'm always going to end here. So I need to write this phrase out. So it says here, write infinitely many or no solutions if necessary. Infinitely many solutions. Okay. Okay. All right, and so that would be my answer. All right, let's do one more together and I'll have you do the next two. Let's do letter B. So I'm going to look, all right, I'm going to notice I'm going to combine like terms here. So this is 1x minus 7x. That's going to give me negative 6. So negative 6x plus 8 equals negative 6x plus 10. So now I'm going to add 6x to both sides. And can you see how they add up to 0 on both sides? So I'm getting them to eliminate, again, the variable. So I'm left with 8 over here and 10. Well, clearly 8 is not equal to 10. This is false. So this is our no solution answer. So you may not, if you solve it a little different than me and don't end up with 8 equals 10, but you still end up with two numbers that are not equal, you still are going to arrive at the correct answer of no solution. All right, I want you to do C and D. So can you pause the video, work through C and D, and then come back when you have an answer, and we will check. Okay, number C, or letter C. I would start by taking away 10 from both sides. So that gives me 4x equals 0. So I'm going to divide by 4. So this leaves me with x. 0 divided by 4 is 0. So that's my answer. So I get one solution here, and the solution I get is 0. Okay, letter D, let's distribute first. So we have 4x plus 10 equals 4x minus 10. Work with variables. So let's take away 4x from both sides. So I can look ahead and see that they're going to add up to 0. So I'm left with 10 over here and negative 10, which is not true. This is false. So here is a no solution. Okay. All right, so we've got a couple of special cases here. We have a regular equation where we get an answer for x. All right. Okay, we really just have one more item to look at here. So let's do a little sorting exercise where you look at these items here. We want to sort these equations into 3 types. Is it a one solution, an infinitely many, or a no solution? So I've got A, B, C, D, E, F, G. And I want to figure out, do they go in the one solution column? Are they the infinitely many? And are they the no solution? So I want to give you a shot to start this, and then I want you to be able to check with me. So I want you to pause and get a head start here. So pause the video and see if you can organize or get as far as you can, and then come back. Okay, so I'm going to start with A. So n equals n. So if I think about it, if n is 1, 1 equals 1. If n is 4, 4 equals 4. If n is 5, 5 equals 5. we are going to get, no matter what n is equal to, it's always equivalent on either side. So this is going to be our infinitely many solutions. Okay, so I'm going to put letter A here, n equals n. Okay, so let's take a look at B. So if I look at this, the one thing I need to look at is, are my variables going to drop out? So if I take away 2x from both sides, I end up with 2x. So my variables are not going to drop out. It's going to be a one solution. I don't need to solve it to see. I just need to know if my variables are going to drop out, because on no solution in infinitely many, those variables drop out. Okay, number 3. So I'm going to distribute in a little bit, and so I'm going to have 3n plus 3. So can you see how my variables, if I have the same variable on both sides, they really cancel out. So they drop out. I'm left with 3 equals 1, which is false. So that's going to be a no solution. Okay, that's going to go there. Letter D, v plus 2 equals v minus 2. So my v's can cancel out. 2 and negative 2 are definitely not the same number. That's another no solution. So I will add it under the no solution column. All right, letter E. Y times negative 6 times negative 3 equals 2 times y times 9. So this is going to be 18 over here. 18y. 18y. Okay, so if I have 18y equals 18y, it's the same thing on both sides. It's a lot like A. So it doesn't matter what I plug in place of y, they're always equal. So this is going to be an infinitely many solutions. Y times negative 6 times negative 3 equals 2 times y times 9. Okay. All right, F. Notice I don't even have a variable on the other side. My variables are not dropping out. So this is definitely a one solution type of a problem. Okay. And then lastly, 2t plus 6. If I distribute in there, I get 2t plus 6. So hopefully you've noticed, if I have the exact same thing on the left as I do the right, then it's going to be equivalent no matter what t is. So that's going to be another one of our infinitely many solutions. Okay. And I actually want to draw you back up to the top here. Look at C, now that we've talked about this. Do you see how the left and the right are the same? So no matter what I put in for x, I'm just going to get a true statement, so therefore it's infinitely many. Okay, well that wraps up our special cases. So if you want to wrap up your notes here, and then feel free to move on to the assignment.